Hello and welcome to Information Technology Video Developer Network. My name is Abdurrashid Hamid. I'm a certified Microsoft specialist working for Cyber Bionic Systematics. In this lesson, we are going to continue discussing our previous lesson, which was methods. The first thing we're going to look at is method overload. Okay, so what is a method overload? A method overload is a creation of several methods, two or more, with the same name but with a different type and or number of arguments. So here you have 1, 2, 3. Three methods, they have the same name but they have different arguments here. Here you can see our argument is in the string type, here it's in the int type, and here we don't even have an argument. So these three methods are different and the computer looks at them as individual methods, so they are all different. Okay, just because we have our string s here we have int I, and here we don't have anything. But then again, this is not like the end of the game. There are so many ways you can create different methods and differentiate them. Okay, now basically it's in the parameters that we change. This here, which is called our returned value, it doesn't really differentiate the methods. Now why is that so? Well, in framework 3 and above, basically in framework 5, .NET framework 5, here Microsoft has created a rule that here when you have your return value, it doesn't affect the method, it doesn't affect the signature. So of course in some languages you can see that the return value, which is here, also is part of the signature. But in framework 5 we don't have that rule. The rule is this doesn't affect the value of our method. It doesn't go into the signature, I mean. So anyway, let's look at parameter sets of overloaded methods can differ by sequence, order, amount, and type. Thus, method overload is necessary in order to avoid creating multiple methods with different names that have similar actions. What does this mean? This means that here you can have 1, 2, 3, or let's say 3 parameters here, and when you change their positions, you have a different method. When you change their type, you have another method. Okay, so even let's say when you have one string here you have string and int, so you have of course two different methods because here you have 2 parameters and here you have 1 parameter. I'll show you that in a moment or two. So let's just go to the next slide and you'll understand what I mean. Here we are. So arguments and parameters. Here you can see we have 2 arguments. Here we have 1, 2, 1, 2, 1, 2. So this method is called method, method, and method. They have 3 similar names. Well, the same names, but their parameters are totally different. Let me just explain. So let's say what's the relationship between arguments and methods. Okay, now here what you can see here is when invoking the method, the arguments are passed according to the given position and type. This is in the positional method. Okay, when you have a method that is called a method here, or you can name your method anything, but when you have a method and you have 2 variables, you have int type and it's A and a string type B. Now what happens is when you're calling this method, here you can see invocation or calling of a method. So when you're calling this method, what you have to do is you have to put your 5, which is an integer value, you have to put it here in the first position. Then hello, which is your string type, you have to put it in the second position. When you change their positions, it won't work in the positional type. Okay, so you have to put them according to their positions. Here you have A plus B, so we're going to 5 hello. This is only in the positional. In the named type, how you can invoke a method using its name, position, or this is just an optional one. So you can also invoke a method using its name. Here if we invoked the method using its position, now we can invoke them using the name. When invoking the method, the arguments are passed according to their name and type. The position does not matter, but the number of arguments must match. here the first thing I want you to remember is the number of arguments. You must have 2 arguments here and 2 arguments here. If you have 3 here and 2 here, it won't work. If you have 3 here and let's say 2 here or 5 here, it won't work. You have to match their positions. Or in later cases, I'll show you how to have 2 here and 5 here or 3 here, and you'll just see how it works as we go on. So here again, we have the same scenario here and the same method. But what is different is calling of the method. The procedure of calling this method is a little bit different. Why is it different? It's different because you can see B in the first position and then A in the second position. Not like here. Here you have to have A, 5, B, hello. In this case, we have hello, 5. Okay? So, it should have been high 5. But anyway, now what we are going to do is we are going to take A and put it in the second position, B in the first position. What allows us to do this is when we invoke the method using its name and this colon here. You must have this colon. You can see double dots here, 1, 2. This is the colon. So if you put B colon hello, the computer understands that you are calling this method by its name. You are calling this parameter by its name. So it will take string and put it in the first place and take this int value and put it in the second place. So this is how you can call a method using its name. Then again, we have another optional type. When invoking the method, it is possible to pass values of arguments in accordance with their position, type, and name. In this case, the arguments to which no value is passed already have a default value. Alright, to explain this in a short sentence, what I will tell you is here we have in the method, you can see it's different from these 2 methods. In the method here, in the parameter of the method, we have assigned values to our variables. So what are these values? These are the default values, which means even if you don't assign any value to this, let's say method, when you call the method, it already has a value. So you don't even need to assign a value. You can see here we have method and nothing inside. So what will happen is it will print out 1 and OK. In these 2 other cases, if you don't put a value, since it doesn't have a default value, you will not see anything. And again, you can use the position. For example, method 5, which means we have assigned a value to A, another value. So we're going to have 5 only. We're not going to see 5 OK, sorry, since we have B here. B has an automatic value. But here, if we were to only write 5, what will happen is we'll only see 5. Okay, nothing like B. So again, you can use the naming system. You see, this is the naming system, yeah? This calling of a method. B hello 1. So here we have assigned a new value to hello 1. So what we are going to see on the board is 1, which is A, the default value of 1, and then hello 1, which we assign to B. Alright, let's move on to the next slide and see other ways of invoking. Invocation of a method by some other method, which means you can use another method to invoke one method. So here we have 2 methods. Method 1, which we named first, and method 2, which we named second. Here you can see all these methods have their bodies. So let's read what we have here. Methods can in their bodies invoke other methods. After the invoked method is over, the invoking method continues its work. This means that in this first method, we are invoking our second method, or we are calling our second method. We call our second method, it does its job, and then it leaves. Then we go back and work with our first method. Okay? So here we go. We go into the first method, console write line 1. We have 1 here written because we're the first method, the body of the first method is being processed now. And then we invoke the second method. And the second method, we go into the body and write line 2. So we write 2. Well, it prints 2 out. And after the second or invoked method has finished its job, it will go back to the first method. So here we have console write line 3 and then 3. So it's first method, move to second method, do its job, finish the body, and go back to first method and continue. So in this way, we can invoke a method in another method. So you have one method, two methods, you can even have three. And each time you can, play all over. Let's move on to the next slide. Let me show you something. So here we go. In this slide, we have a very interesting procedure or process. It is called recursion. Recursion is an invocation of a method within itself directly. This is called simple recursion, when a method invokes itself or through other methods, and which is called complex recursion. So when a method calls itself directly, we call it simple recursion, and when a method calls itself through other methods, then we call it complex recursion. Now let me just explain what this means, and you'll see that it's very easy. Here in the main part, we have our main entry point. So in this main entry point, we're calling a method recursion 2. We mean we want it to run 2 times. So what happens is, from here you're being directed to the body of our method here. So we have a method here named recursion, and in its parameter we have a counter, an int type. And let's say that we assign a value of 2 to this parameter, okay? So now the value is 2 because we have 2 here and we have 2 here, meaning run 2 times, 2 iterations. So in the body of this method, you have a decrement. Remember this sign, decrement now. So counter minus 1, 2 minus 1 is equal to 1. All right? Now console write line, print out this, yeah? A colon amount, or should I say value of counter. So A, what's the value of our counter? 1. So we have 1 here. You can see it here. A semicolon 1. So we put the value of 1 here. Next, we have a conditional statement here. If counter is not equal to 0, then recursion counter. And is our counter equal to 0? No, it's not. It's equal to 1. We have 1 here. So this is where the tricky part happens. The computer now copies this method. It has a copy of a method and it runs it somewhere else and then comes back here. It runs it one time and then comes back right in here. But this procedure doesn't affect this procedure. It just affects what's printed on the screen. So let me show you what we have. Remember here the value of our counter is 1. So we take 1 here. You can see this method is an identical copy of this method. It's just a copy. So here our counter is 1. Counter minus 1. Now our counter is 0. Console write line. It means print. What's the value of our counter in this copied method? It's 0. So we have 0. A colon 0. So we have A colon 0. You can see how the copied system works. Then it moves into the conditional. If counter is not equal to 0, recursion. That means run it one more time or the number of times. But recursion is equal to 0. Counter is 0 now. We can't run it again. So what do? Console write line B, counter. So we have it here too. Counter now is 0. We put counter into here and you have B colon 0. Next, what happens is this copied method has finished its work. So it will go away and it will give back the method to this original method. So we come back into the original method and console write line B. But what's the value of our counter in this original system? I told you that the copied method doesn't affect what happens in the original method. Here our value for the counter is still 1. So print B and put the value of counter or assign the value of counter to B. So of course our counter is 1 and we're going to have B1. You can see it here, B1. All right, I think you have seen enough in the presentation. Now what I want to do is let's go to our practical class. Let's go to the practical part and see what we have there. We'll see all these things in detail now. Starting our practical class, what we should look at is method overload. Since it's the first thing we looked at in our presentation, I only think it's fair if we look at it right here too. So overload methods can differ by type and number of arguments, as well as ref and out parameters. So ref and out parameters also can change a variable, but I will show you that, and I will show you some restrictions that ref and out have. So here in the first one, you can see below here there is nothing, so I don't have to open it. Just write S, write hello, maybe here write I, yes, write D. Let's see. So the body is all equal. What I just want you to pay attention to is just the name. Now all these methods have the same name: function, 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 function. You can see we have almost 8 of them here. Okay, well, let's say 7 for now. I'll show you the 8th one later. So we have 7 different methods with the same name. Now we can call these overloads because the parameters or the list of parameters here differs. You can see they all have a different list of parameters. Let's take a look at line 11. In line 11, what we have is we have a function, a method called function, but there is nothing inside, so it doesn't have any parameters there. It's empty. Okay, and of course void means it doesn't return any value. You can see it here. Specifies a return value type of a method that does not return a value. So void doesn't return any value. Now just below the first overload we have the second overload, and you should notice that in the second overload we have a string typed variable here and s here. So we have a parameter here. At least we have 1, but it's still 1. You know, it's not empty, it's 1. So these two methods are different. So we have first overload, second overload. Now the third overload is similar to the second overload, but in this case we have int, meaning integer. Yes, so we have integer here, string here. So because of these two different types of variables and two different types of parameters that we have here, these functions are different, these methods are different, and these overloads are different. In the fourth overload, it's the same thing. We just have double here, and here we have int, here we have string. So double also shows that this is another method. Let's go down a little. Here you can see we have string s int I, but we have string here, we have string here. Well, we don't have I here, and we have I here. So this is a different overload on its own. So this is the 5th overload. The 6th overload, I want you to pay attention to the 6th overload because it's a copy of the 5th overload, but what's happening is we have string here, it's been put into the 2nd position, while in the 6th position, in the 5th overload, it's in the 1st position. And int, which in the 5th overload is in the 2nd position, now in the 6th overload, it's in the 1st position. So just by switching their positions, you can change the method. You have a different method all over. It's a different overload. So the computer will look at this overload as a different overload. Now, the 7th overload, which is in line 41, it's the same thing with the 6th overload. But the difference is here you can see ref. This ref here, which we don't have in the 6th overload, has showed the computer that this overload is a different overload. It's a different method on its own. So the computer will look at it as a different method. Overloaded methods cannot differ by return values. Well, I told you that in .NET Framework 3 and above, well, there's a new rule according to Microsoft that we should not differentiate overload methods by their return value. We can only differentiate them by the parameters in them. So let's go to line 41. In line 41, we have static string function, string s, the 8th overload. What is this? Let's try, and it's being commented now, but if I remove this comment, you'll see that it has a problem. Here we have, of course, expected, which means the computer is looking at this not as a method. Okay, it's looking at it as a line or something like that. So basically what is happening here is that we have similar thing here. You can see here we have string. So if it's string, it's not possible. Here you cannot have a method with a string because it only returns a value of void or int. It can be int, it can be void, but it cannot be string. So that's our problem here. That's why the computer is not looking at it as a method. Let's go on. Here we have return s. Of course, it won't work. We already know it won't work because if we take this out and this out, I told you that here we have a problem with string, so it won't work. Now, overloaded methods cannot differ only by parameters ref and out. What this means is if you have here, for example, ref in the 7th overload, and in the 6th overload you have out, for example, okay, the computer will look at them as the same overloads. Why? Because ref and out on their own cannot differentiate between overloads. It cannot show the difference between overload. So don't use ref and out because you want to have two overloads. It won't work. Okay, but we'll see something else. Here we have what? The 9th overload. Overloaded methods cannot differ only by, okay, we've seen that, static void function out in, oh, I showed you this. So if you have out here and you have ref here, it won't work. Okay, this will be a different thing altogether. Let's see, 1, 2. Now you have expected, yes, we know, but what I'm trying to tell you is here you have the same thing here in line 41, but in line 41 you have ref, here you have out, but you can see that the parameters are the same, string s, int I. The only difference is ref and out. So this is a bad practice and you shouldn't differentiate your overloads this way. Now let's go into the main part and see what will happen here. Here in line 61 you can see we have an empty parameter list here, but we can still call the method with an empty parameter list. We know because, well, it allows us to do so. So when we run this program, what do you think will happen? Well, it's very simple. What will happen is function and this empty overload, we go to the first overload and look at what we have there. Let's go to the first overload, open the body, and we have hello. So what we should expect there is hello in the first position. Let's run it and see. You can see that, yeah? Function first overload hello. The second overload we put a value of a in it. Okay, so let's see how that works. You can see we only have one variable and it's a. So when we go to the second overload, you can see we have right line s, string s. String means we're going to put something of a character type, and a is a character typed symbol, so a is going to be here, and right line s, so we have a and it's printed out. Overload 3, we put 1 in the list. What do we have here? Int third overload, int I, right line I. Yes, it's correct. 3 is an int typed variable, so we can put it right in here and we'll have, sorry, it was 1, yeah? The fourth one should be double because we have 3.14. Let's go up, fourth one, double, and write the value of d. What is d? D is 3.14. The fifth one is a combination of string and int. Let's go up, fifth one, string and int. So we go up here, you have string and it's concatenated with int. This is I, S, and what we should see here is B2. Simple. Sixth one, it's the other way around, int string. Sixth one, int string. Very easy. And now I want you to look at this seventh one. In the seventh one we have ref. But before we call the function, what we did is we applied, or should I say assigned, a value. We created a local variable in line 68 and assigned a value of 5 to 8. This local variable is of the int type. So it's an int type local variable named variable and assigned 5 to 8. So now we have ref variable and d. What is this ref? Why did we put it? Because we can change the value. Ref allows us to change the value of a variable. So here we have variable, which is 5. Here we're going to have 5, and d, well, 5d in other words. So let's just run it and see. You can see 5d, 3c, b2, 3.14. So all of them are just here. Now, enough of this. I think you're overloaded already. Let me just try and move to the next example and we'll see. All right, named arguments of methods. Now remember that we could name them by position, name, or optional, yeah? So we can call a method by its name too. Let's look at how that is done here. In line 9, we created a method, an int type method named difference, and assigned 2 parameters to it. In its parameter block, we have an int type variable named height and also an int type variable named width. And in line 11, we want this method, in the body of the method, we want it to return a value of height minus width. So in other words, we want this body to return a value that is the difference between height and width. We want to have the difference, and that's why we named our method difference. Well, I told you it's a good idea to name your methods with respect to what their function is. If it's subtraction, you can name it subtraction, difference. If it's addition, you can name it addition, whatever you like. So it's a good practice. Now, in the main body, what we have here is, in line 17, we've created an int typed variable named difference and assigned the value of this function. We're calling this function now, okay? We're calling it now. So what do we assign there? 5 and 6. So here height is 6 whatever, and width is 5. 6 minus 5. Of course, 6 minus 5 is 1. So the difference is 1. So we write console right line. The difference is, and the value of the difference. Okay, this is one way to do it, and here you have another way to do it. It's even easier. You can see it's very clean here and compact. So in line 24, we have created a variable named difference and assigned the value of this method here. We are calling this method that is called difference, and we put width. This is using the name width 5, height 6, whilst here we have 6 and 5. Why? Because here we are using a positional method. Height is in the first position, so we have 6. Width is in the second position, so we have 5. But in this case, we are calling width first, and then we put height second. That's why we have these 2 dots here called colons. Okay, so now you see how you can call a method using its position or its name. And console right line. The difference is, well, they will give you the same result. Let's just run it and see. And here you go. The difference is 1 for this, and the difference is 1 for this. There are 2 different methods of doing something. Now, this is exactly the definition of a method. A method is just the way you do something. You can do a lot of things, or you can do the same thing in different ways. If I ask you to, let's say, pick a pen, you can pick it with your left hand or right hand, or with your leg, or with both hands. So, but you're still picking a pen, but using different methods. So this is basically how methods work, and how to call a method using its position, and also how to call a method using its name. Remember, when you're calling a method using its position, you have to take into consideration where you put your 6 for your height and width for 5 for your width. So you have to consider its position, okay? But when you're calling them using the name, you can just call the name and put them anyhow you want, any position, but you have to write the specific name and a colon and then assign a value or put a value to it. Let's move on to the next slide and see what we have. Here is a very good example of how methods are called, we have 4 different overloads here. 1, 2, 3, 4. Okay, and then in the body of the main part we have called each one of these overloads in a different way. So let me show you how to do that and what differentiates them. But first of all, let's take a look at these methods. Okay, here we have operation, nothing inside. We've created a method named operation which returns nothing and has no input there. It has no parameters. Its parameter list is empty. But then look at this operation, and then we assign value, or let's just say val 10 and 12. Okay, so when you call this method, it's going to display 10, 12. Here we have, for example, nothing inside 2, so we're going to see val 10, 12. Okay, because there is nothing inside, we are free to write this. Let's see. You have, when you call it, it's going to just say 10, 12, val 10, 12, val 10, 12. Now, moving on to the second overload, in our argument list, we have one argument, a string typed argument, and it's named value 1. Okay, so when we call this method, what we're going to have is operation value 1, and then we have 10 and 12. So, but what can we do with this value 1? Value 1 here, we can rename it, for example, new val, or you can change whatever you want here. Let me leave it as new val first, run the program, then you see it here, new val, it has taken it from here, and then when we go up, where is the second? So you have new val, which we just rename this value 1, and 10, then 12.2, 12.2. Okay, so let's close this and change the name of our new val to, let's say, Alex. Okay, so Alex. Now when we run the program, what we're going to see is Alex 10, 12. Alex 10, 12.2. Okay, Alex 10, 12.2. So of course you can change the name here. Let me just take it back. Now of course you can change the name as you wish, and in the third overload we have new val, and then again we have this space and 11. So what does this 11 mean? Why do we have it here? Let's go to the third overload, and we have, you can see we have 2 values that we can change here, value 1, value 2. So in the parameters here we could change 1 parameter, and here we have an option to change 2 parameters. So here we named it new val, here we put 11, and here automatically we have a default value of 12.2. So here new val 11 and 12.2. Let's see it. Here it goes, new val 11 and 12.2. Okay, so it's very easy and it can be done like that. Now in the next one, what we have is we have a case where all our parameters can be changed. So I expect value 1, value 2, and value 3 maybe. Let's go to the fourth one. Where is it? So we have value 1, value 2, and value 3. This case we're just writing it like, let's say for example, sorry, here what value 1, value 2, value 3. We have them in this order, meaning you can change value 1, value 2, and value 3. But take note here, value 3 is in double, meaning it takes some, let's say, fractional numbers, yeah, or better called double precision floating point numbers. But you can see here it's written, well, it's gone. Okay, it's written. So an integer holds a full number, a whole number. So whole number, fractional number, and here it holds some characters. So here you can write your name, here you can put your age, and here you can put, let's say, I don't know, anything that has a point in it. So when you run it, you have all the 3 parameters that we put: new val 11 3.14, new val 11 3.14. So it's working. But as long as we don't like mix them, their positions have to match, okay? Or else we have to use naming system to call them. Let's move on to the next example. Is this the 4th example? Let me see. Oh yeah, good one. So here we have another way. The method is invoked in the same way if there are overloads. So you call them the same way even if you have overloads. But what I want to show you is how to change their positions. Okay? Just as we discussed, I'll show you here. So in line 11 we created a method named operation which has 1, 2 and 3 parameters, and it returns nothing. It's void. Then in line 12 we print out the value of our parameters to the screen. Now in the main body what we have is we've called these methods 1, 2, 3, 4. We've called all these methods or overloads individually, and it's similar to what you have seen there. It's the same thing that you have seen there. But what I want you to pay attention to is it is not possible to put the third parameter value 3 and assign it 12.2 instead of 2. So what this basically means is you can put this one in here. You can take just this and put it in here because this has 12.2. It's a double type, and this has just 10. It's an integer type. So of course you will lose your precision. Remember, or you have to do casting. Remember, casting is conversion from one type to the other, in which case here you will lose your 0.2. So then we go on a little bit down and see it is not possible to put the third. Okay, we read that 12.2 cannot be converted into int. Of course it's double, except if we want to do a casting. C# is trying to leave as default the third parameter but not the second. So what this means is when you are trying to put third parameter first, let's show you here in this example. What's happening, it's very easy. Relax. I know it's a little bit confusing, but relax. So when you write, for example, new val, well, yes, you can change the name. Of course, val, we have val here, but you have new val, fine and good. Change the name, value 1. It's a string type. You can change it. Then after your comma, you have 12.2. So why do we have an error here? The best overload method match for, let's see, argument 2 cannot convert from double to int. Okay, this is just an old error, don't worry about that. Here we have argument 2 cannot convert from double to int. What does this mean? If you want to just pin this in here so that you can see all your errors, and you can just click on this pin, but if you don't want to, just auto hide it. For example, I like it to be neat and clean. So here you can see this is our mistake. We've checked our error list and it says argument, what? Argument 2 cannot convert from double to int. So what is this argument 2? Our argument 2 is this, and it cannot convert from double to int. We cannot put it, it's in double now, and we're putting it in the place of int. Do you understand what I mean? Value here is new val. It's a string type. Yes, string type. You can see it here. String type. So of course we can put new val. String and string, it's okay. Then the next one we have is int. So the computer, although we are trying to put this value in here, the computer is not looking at it like that. The computer is working with positions. 1, 2, 0, 1, 2. So here 0, 1, 2, and here too 0, 1, 2. So what is in 0? String. What is in 1? Int. So why are you putting double? It's not gonna work. That's why you have an error here, or that's why I have an error. But that's just an example I want to show you. In this case, it is possible to use named parameters. They consist of a parameter name, a colon, and a value, of course, that we pass. We can pass any value we want or assign any value we want to it. So if you want to carry out this same procedure that I just showed you, that's to make this possible, and you don't want to get an error, what you have to do is you have to use their naming. You have to call them by their names. New val, we know, of course, is in the first position, sorry, 0 position, so we don't have to change its name and we don't have to call it by its name. We can just put it there. Then, now look at this, value 3 and this colons here. Okay, so value 3 and this colons is telling the computer that I am calling value 3, not value 2. So put value 3 in the first position. Okay, so the computer now will understand and put 12.2, the assignment sign, into your value 3. Now this is how to call a method using its name. Parameter name, sorry, how to call a parameter. Parameter name, you put it here, a colon here, and of course the value here. So you can call a parameter by its name and it will be correct. Operation, and here we have, for example, if I don't want to use this, okay, I don't want a name, I don't want val, I don't want value, I don't want new val. What I just do is I call these two that I need, value 2 and value 3, which are here, value 2 and value 3. These are only the ones that I want to see printed. I don't want to see val printed or new val or whatever. So I call them by their names too. Value 2, colon 33. Value 3, 12.2. And now they display this. Okay, let's run this program and see. So here we go. You can see the last one we have just val 33 and 12.2. So I'm assigning new values to it, but I don't have to change or I don't have to write whatever is written there. I leave it as it is. So 33 and 12.2. Of course, I can change it and call them by their names too. All right, let's move on to the next example. The fifth example. Returning values from the method main, from the main method, okay? Returning values from the main method. Upon completion of a program, it is possible to return the value of the main method to the calling process or operating system. Well, what this means is whenever you call a method and the program completes running, what it will do, it will send, it's possible that it will send a message to the main method telling it that I have finished and everything is okay. Usually we have zeros there. Any other number that is printed apart from 0, it means there is an error there, and the number of the error describes the error. That is only known to the people who created these programs and the people using them. Okay, that's between them, not between us, so we don't care. So, as a rule, the value returned by the main indicates normal completion of the program or its emergency completion due to the prevailing abnormal conditions of performance. So, 0 return value usually indicates normal completion of the program, and all other values indicate the type of error occurred. Okay, fine. Now here what this is saying is in line 18 you can see we have main, hello world, and key. Return 0, which means this program is okay and there is no problem, because 0 means we have completed it, finished. If we have returned, for example, 5 here, it means there is an error in this code, and that number 5 will describe somehow the error in the code. So this is just something I want you to know, that where you see numbers that are returned to the main method, it means there is an error there. Okay, let's see example 6. Returning values from the main. Overload of a method is possible. The entry point of the program may be the method main, which returns a void or int value. Now a method where you have main here, okay, you can only return an int typed or void type. You can't have string here in your main method, okay? You can't have string. So here you have in line 15, you have static string main, and in your parameter list, you have a string typed variable named argument. Okay, then in the body of this method we have a return value of hello with concatenation of argument and an exclamation mark. So whatever we write here will be put in here, and it will be assigned concatenated with this and printed out. But this is not an entry point, it's an overload. Why? Because we have string here, and I told you that the entry point can only return a value of int or void. So this is our entry point because it has int. String is just like an overload to the computer. So in line 24, what we have done is we've created a string typed variable named @string. Remember that if you put this @ here, you can name variables using keywords. Then assign the value of main world. So we're calling main world here. Main world is just like our what? Our method. We're calling our method. So calling the method, now we have world here. What it's going to do is when we call the method, let's step this program. So we're here. Now we're going to call the method. When we call the method and go in the method, we already have hello plus your argument. And what is our argument here? Our argument is world. So hello world and an exclamation world. So you can see the value of argument here is world. And then we go back and print it out. Hello world. Now if I change world here and put something else and say hello, let's say Victor. Oops. Hello Victor, and run this program. You can see hello Victor, and that's it. So this is how you can this is how, of course, you can simply make a mistake and think maybe this is my entry point. No, it's not your entry point. Just because it's called main, it doesn't mean it's your entry point because it has a string. Your main entry point must return a value of int or void, and that's it. All right, let's move on to the next exercise 7. All right, now in this example we're going to look at recursion. I hope you remember what recursion is. So here we have in line 11 created a method named recursion, and of course it returns void. Okay, so it's correct. A method can have void or int. So here we're correct. And in the parameter we have an int typed variable named counter. Okay, I just named it counter because I wanted to count how many times. Of course you understand what I mean. And in the body of this method we have a decrement. Do you remember decrement? Reduction of one figure each time it passes here. So it's like -1. Okay, and then in the 16th line we print out this message to the screen and put this value of our counter in here. So it will read the first part of the method something from the counter. Then in line 18 we have a conditional sentence here. Okay, and of course in the parameters we have counter is not equal to 0. Remember, this exclamation mark is not an exclamation mark, and an equal to sign shows that it's not equal to. So it's not equal to 0. If counter is not equal to 0, recursion counter. So here we're supposed to have a number. So we call recursion if this number is not equal to 0. And what does recursion do? Recursion subtracts it or decreases it by 1. So we have a decrement here and conditional here if it's more than 0. And then again we print out this message to the screen. That's in line 21. The second part of the method something, and we have a counter here. Then now this is the main entry. Remember, void main. We have main, it's the main entry point. It cannot have any other value here except int or void. So main body, we are calling our recursion and we have a count of 3 times. So now we're calling recursion run it 3 times, what we want it to do is to run 3 times. 1, 2, 3. Okay, so we have 3 counts. Now this count here is going to be 3 later on. Let's step the program together and see what we can do. F11 if you have forgotten. So main point, of course, we are going into the main entry point, and we have recursion 3. You can see this, and this have been highlighted. So our counter here is 3. We go up. What do we have here? 3. Alright, we go into the body. Counter is 3 now, and we subtract 1. Counter is 2. Counter 2. So something will be displayed, the first part of the method 2. Okay, let's check the first part of the method 2. Alright, we're not done with you, just stay here. Then we move down to the conditional part. 2 is not greater than, is not equal to 0. Yes, it's true. 2 is 2 and 0 is 0. So recursion counter. So what are we doing? We're calling it again. How many times? 2 times. Until 0 is equal to 0, or this number is not equal to 0. Is equal to 0, sorry. So we go up. 2 minus 1. 1. Now we go in here and we write 1. The first part of the method 1. Go back. Counter 1. So it's more than 0. It's not equal to 0. So we go back. We go into the body and go up. Counter 1. 1 minus 1. 0. Console. Write 0. Go out. The first part of the method 0. Come back. Now console, write line the second. Since counter is equal to 0, we are not going back. We'll go to the next line. In line 21, console, write line the second part of the method. We have 0, so we put 0 here. The second part of the method 0. And then look at this. We go back to our recursion. You see, we jump from here, we go to recursion, and we repeat it 3 times too. Now we have opposite, yeah? 0, 1. If you do it again, let's do it to the end. Okay, let me just run it. It's here. We have the second part 1, 2. So 0, 1, 2, 0, 1, 2. This is how recursion can be applied. I guess now you understand what recursion is. It's just calling your method. In this case, recursion is called 3 times in this condition. It's calling itself. In the body of our recursion, we are calling recursion itself, meaning it's a simple recursion. Let's go to example 8. Now let's look at a complex recursion, an invocation of a method by itself using another method. Okay, using another method. Fine. So here what we can see is we have our method here. In line 11, we've created a method named recursion, and it has no return value, and in its parameter list we have an int typed variable named counter. So in the body of our method we have a decrement, and in line 15 what we have is we're printing out the value, the first part, second part, and so on. So the first part, and then we put that, and in line 17 we have a conditional statement here. If in our conditional block here we have counter is not equal to 0. If the counter is not equal to 0, call our method counter. So if our counter is not equal to 0, we are going into a method. Well, where is this method? It's here. So if this counter is not equal to 0, we jump straight up and we come to line 23. We don't write this. So we jump up and come here. Fine and good. What's in here? Here we can also see that it's a method. It returns nothing. and in its parameter list it has an int typed variable named counter. And in line 25, let's go into the body of this method and see. In line 25, in the body of this method, what we have is we're printing out something with the value of this counter. The first part of the method is, let's say, 0 or 1. And only after this, so here we have one method, recursion, and recursion is calling another method, which is this one, and this method is calling back recursion. So this is like a complex type of communication. Let's imagine that I created this program and then I gave it to you and you created your program. So if I create my program and I want to somehow connect my program with yours, I want to use your code, what I will do is I will just call your method. I called your method is working for me, your program is working for me, and then later somewhere in your method I will call back my method. So this is one method, recursion, calling another method named method, and then method will call recursion back. Okay, so it's like calling one method from another. Then after that we have our main n3, and you can see main n3 is just calling method 3. Okay, method and 3 counts. What is the method? You know the method, we have it here. So we're saying run this 3 times. Okay, let's step the program and you'll see. So we start from here. We're running this program, method 3 counts, go up to method. In the body of method, what do we print? What's the value of counter? 3. Where did we get it from? Here. 3, 3. Then counter 3, so it should print the first part of the method 3. The first part of the method 3. Let's continue. Then here you can notice that we're calling recursion 3 times. Okay, so let's call recursion, and what do you expect? We're going up. We're calling this method called recursion, and here we go. We're here, and what will it do? It will reduce it by 1. So 3 here minus 1, 2. Okay, then it will print out something. The first part of method recursion 2. Why? Because we have 2 here. Let's just take this out and bring it here, and we have it here. Oops. The first part of method recursion 2. You can see here. So from here, where do we go? Let's step it. We go back to our method. And what does the method do? Prints out the first part of method, and now we have 2. The first part of method, method 2. Call recursion, counter 2, counter 1, counter 1, so we should see something 1. The first part of the method recursion 1. So this method is called recursion, this method is called method. Where is it? It's here. So it's just a little mistake, I'm sorry, but I would have named this method another thing so that you don't get confused. Method. It means a method that is called a method. So this method, and I named it method. Just to show you that it's a method. It's not a very good example, but anyway. So let's keep on running. Now what's here? 1. 1 minus 1. Of course, 0. So this is what I was looking for. If counter, which is 0 now, is not equal to 0, which is false, go to method. But now it's false. Just right line, and what happens? We go out. Okay, so of course you have a lot of things you have to repeat it. 1, 2, 3, 4. I think you have the idea and you get it. It's not something difficult. This is just, we're calling a method in the body of our method called recursion, and in that method we also call our method, first method. So this is first method and this is second method. Okay, So the first method calls the second method, and then again within the second method it calls itself. This is called a complex recursion. I just wrote recursion here. I just want you to know that this method is the method that is doing the recursion process. All right, let's move on to the next example and look at display in binary format of a number that is passed in decimal 1, okay, or let's say in decimal points. So here we have binary digits. What do we have? In line 9 we've created a method named converter, and it has one variable, or it has one parameter in its parameter list, and it returns nothing. It's void. Okay, now in the body of this method we've created another variable, this time a local variable named temp, and it's an int type. Now in line 13 we have assigned a value to temp. The value of temp is n, which we got from here, and remember the sign. This is not percent sign. This sign is a sign that shows remainder, okay, like remainder. If I divide 7 by 3, I'll get 2, okay, because 6 divided by 3 is 2, but then I have one remainder. So this is what will divide any number that we put in here by 2 and save the remainder, assign the remainder to temp. Now in the next line, in line 15, we have a conditional statement. If n, which is here, is greater than or equal to 2, then here we have converter, call converter. So we're going to call here. If we have a number that is greater than 2, then we call this method, which is converter, and what it does is it divides n by 2. So we divide n by 2 and call converter and get our remainder and divide it and call converter again until we have a number which is less than 2. Then you have console write line temp. What is temp? Temp is the value of this operation. Okay, now in the entry point, now this is just our method, the body of our method and the signature of our method. Okay, so in the body of our main entry point, our main method, we have created an int type variable named n and assigned a value of 255 to it. Then in line 25 we called converter, or you can say we invoked converter. Okay, so we called converter, and where are we going to from here? We're going up right into this body. Okay, let's tap the program. Where are we? We're here. Value of n 0 now, so we assign 225 to it. Here value of n is 0, value of n is 0, and here too. So now we've assigned a new value to n. What is the value? 225. Okay, sorry, 55. So we have 255, and we are calling converter and passing n to converter. We're passing 255 in other words. So we'll jump up now. You'll see it. We're here, and temp right now is 0, n is 255. So we divide 255 by, let me say 2. We'll just see, we'll get a remainder. What's our remainder? Our remainder is 1. How many times will we get 2's in 255? I don't want to know. What I want to know is the remainder, and the remainder is 1, because we're converting to a binary type. Remember, binary digits. So what we're expecting to see are 1's and 0's. So after this step, we step down, and here we have n is greater than 2. It's true. So what do? Let's step out and still check that. N is 255, which is greater than 2. It's true. Call converter. We go up. Now n is 127. Remainder 1. 127 is greater than 2, which is true. and we go up again, and we continue. Let me just press it and hold it. So after that, our remainders that we have here, temp, remember we had 1 1 1 1 1. So this is our result. This is 255 in the binary format. This is how calculations are done. If you have a small program that calculates and converts from decimal numbers to binary numbers. And this is how it works. This is how you can use recursion. This is a very good example of recursion. It repeats, repeats, repeats. It calls itself, always. Have from another method, it's calling itself and working with it. So this is how it works here. Let's go to the next example and look at another thing. Here we have finding the greatest common divisor, GCD, of two integers. Well, it doesn't matter. Anyway, we are going to try to find out some common divisor between two integer numbers. Our two integer numbers are 15 and 33. So if you run this program, what you should see is, you will see A 15, B 33, GCD 3. So 3 is the most common divisor. But let's just step it and see how it works. Anyway, you know about recursion now. What we're going to do is in line 9, we've created a method, an int typed, that returns an int typed value, and in the method we have two parameters. What are the parameters? Int A and int B. Then we have a condition. If int A and we have a remainder B is equal to 0, return B. If it's not equal to 0, remember that these two equal signs mean equal to. They are not assignment signs. So return B. Else return calculate this. What is calculate? This is our calculate. Okay? And this is our formula that we put in here. So from here we return to calculate. Else we'll just return this value. Now, in the main body, what we are doing here is we'll first find the greatest common divisor of two integers. Print that first, and then in line 29 we've created an int typed variable named A and assigned a value of 15 to it, and B and assigned a value of 33 to it. And in line 23 we're going to print out this line. A is equal to 0. Well, this 0 is 15. B is equal to 1. This 1 is 33. And GCD is equal to 2. What is our 2? We'll find out now. Then 2 is this value. Okay, since we have A put into 0, B put into 1, then now calculate A and B will be put into 2. And whatever our result is will be displayed right here, and we can read it, have a read queue here. Then in line 29 we have a second variant of doing it. You can write it like this if you wish to do it. It's also an okay situation here. It's okay to calculate like this. We are just using while instead of if, so you are making your program a little bit shorter in this case. Instead of if, you are using while. While B is not equal to 0, assign the value of A with a remainder of A is equal to B to B and return A. So this is the second way of doing it. Now let me step this program. It's not going to be a very long program. And here we've printed this out. It's here, finding the greatest common divisor of two integers, B 33. We write this. What is A? Let's see if it has printed it now. Let's move out first. Okay, we go here, check, jump up again, well, we're going to jump up today, and it has printed it now. So after going back and forth, what you'll have is A is equal to 15, B is equal to 33, and the denominator is, the GCD is equal to 3. This is also an example of recursion, but I don't think you need to find any, well, most common divisor. I don't think you have to do that. The next example is a little bit more interesting. Finding factorial of a number. Alright, you remember what factorial is? Okay, factorial of 4, remember? 1 times 2 times 3 times 4. Alright, now in line 10, what we have is we've created a method, an int type that returns an int typed value, and in the parameter list we have a one parameter. We only have one parameter, which is int typed and named n. Then in line 12 you can see we have our condition, and in the parameter of our condition, in the conditional block, what we have is n is equal to 0. Then return 1, else return n multiplied by factorial n minus 1. Don't worry, this is just mathematics, and I know a lot of you understand it even better than me. But anyway, let's just go into the body and call our method, and I'll show you how it works. You don't really need to know a lot about mathematics before you can do this. So F11, and we're in the main entry point. Here we have factorial of a number. What number? Number 4. Okay, it can be any number, but I just, well, wanted to use 4 because we've used 4 already, and I thought it would be easier for you. So from here we're calling factorial 4. So let's go up to factorial, the method called factorial. And what's the value of n here? 4. Where did it come from? Here. We put it ourselves. And 4, then if 4 is equal to 0, return 1. But is 4 equal to 0? No, it's false. So what do? We move into the else block. You see, after checking, we moved into the else block, and here what we have is 4 minus 1. Of course, we'll get 3, and n multiplied by factorial 4 minus 1. So what is n? 4. 4 multiplied by 3. You see where we got our 3 from in this formula. 4 multiplied by 3, we have 12. Okay, so keep 12 now in your mind, and let's move on, because it's not going to print it here, so you just have to keep 12 for now before we get our final answer. So we go down. What's n now? N is 3. Is it equal to 0? False. So we don't go in here, we jump into else. Now n is equal to 2 because we've multiplied, we've subtracted 1, and you can see it here, n3. Yes, so when we move out, n will be 2. 2 multiplied by our factorial. What did we have there? 12. 2 times 12. Remember, we kept 12 aside. Now we're going to use it again. 2 multiplied by 12, we have 24. Okay, so we go up, n is 2, go here. Now n is equal to 1. 1 multiplied by 24, it's still 24. n, 1 minus 1, it's 0. So here n was 1, but when we move out, n is 1 is equal to 0, false, and we try it again. Fine. 1 multiplied by 24, 24. We go up. Now n is 0. If n is equal to 0, return 1. So 1, let's return it. And here you have, it will just, this is just the computer running, and you have factorial of 4, right line here, you can see 24. How did we get it? First of all, we took 4 minus 1, 3 multiplied by our initial number 4, we got 12. Then we went up, checked, well, 3 is greater than 0, it's not equal to 0, and we come back. Then we have a subtraction here, 3 minus 1, 2. And remember, we had 12 on the side. So 2 multiplied by 12. Now we have 24. 24 But here we have 2, so we go up. 2 is greater than, so we subtract 1. Subtract 1 from 2, we'll get 1. 1 multiplied by 24, it's still 24. So we go up again, come down, minus 1, 0, then we go out. Very simple. So after we finish all this, what we should see here is 24. Very simple and very easy way of doing it. Now, this is the end of our examples and our exercises for methods. Let's go back to our presentation and see if we have any questions. Just a quick review. We have method. You remember what method overload is? It's when you create several methods with the same name but different types or number of arguments. Then you remember the parameter sets of overload methods can differ by sequence order, meaning you put this, maybe if you have 2 or 3, you put 1, 2, 2, 1, 3, 2, 1, 1, 2, 3, 2, 3, 1, something like that. So order, sequence, and amount. If you have 2 and you have 1, of course they are different. Next we move. You see how you can call methods. You can call methods according to their position. Of course, you remember 5, it's in A, hello, it's in B, fine. Or you can call them by their name using this method. You have B and a colon, and then your value that you want to assign to it. A colon value. And then you have your optional way of invoking or calling methods. And this way it gives you more options. You can use an empty type, you can use your positional type, and you can also use your named type. So you have more options basically here. And here we looked at invocation of a method by some other method. So calling of methods from another method. We have one method and the other method here. This method calls this method works for this method, and it goes out. Simple. Remember what happened here. Console write line 1, 1. Then call second method. We call the second method, we moved in here. Console write line 2, 2. I finished my work, thank you, and come back to our first method, and our first method continues. So this is how you can call a method using another method. In this slide we looked at recursion. Remember what recursion is. It's the invocation of a method within itself directly, then simple recursion, or indirectly through other methods called complex recursion. Recursion, main recursion. So this method is calling itself, it will work, copy itself, do the work again, give it back to the original, do the work, and print whatever we have here. So, and thank you very much for your time and attention. See you in our next lesson.